Hello, my name is Wong, and I'm a PhD in Cultural Studies from the University of California at Davis. My presentation looks at how Jane Jacobs' ideas of urban complexity are referenced and alluded to in a set of contemporary popular urban discourses that I identify as global sustainable city discourse. This discourse presents the city as socially, economically, and environmentally beneficial and sustainable, and also humanity's best hope for solving the global ecological problems of the 21st century, through the idea that the city can transform the planet with its individual self-organizing dynamics. This presentation identifies some epistemic limits of this discourse, and thus critically situates Jane Jacobs' ideas as the discursive basis of a contemporary infrastructural imaginary of neoliberal urban innovation. In the last 30 years, the trope of the global sustainable city has emerged in popular and professional discussions of sustainable development and urban innovation. Published in the form of commercial publications and grey literature on policy, design, and global trends, it is produced by an international research industrial complex that includes urban designers, architects, and planners, as well as urban policy think tanks, international press, multinational conglomerates, and United Nations agencies. Global Sustainable City Discourse frames global urbanization as a phenomenon of planetary ecological scale, and humanity as historically becoming an urban species, or Homo urbanus. This discourse references and alludes to tropes of urban complexity and nonlinear dynamics in describing the city as a self-organizing entity. An example is multinational conglomerate Siemens' flagship smart building, the Crystal, which is the site of an exhibition on urban sustainability and urban futures, as well as the home of Siemens' Center for Competent Cities. Located in the Green Enterprise District of London, the building is architecturally designed as a crystalline structure to embody the concept of complexity. An underlying premise of the Crystal's exhibition is that the city is the solution to the planetary forces of change, such as climate change, through the application of infrastructural design and technology. This notion is also articulated by a genre of trade books on cities that has emerged in the last 10 years, written by consultants and urbanists that promote the city as a genus of civilization. Exemplified by urban economist Edward Glazer's Triumph of the City, How Our Greatest Invention Makes Us Richer, Smarter, and Greener, urbanist Leo Hollis's Cities Are Good for You, The Genius of the Metropolis, and urban strategist Jeb Brugman's Welcome to the Urban Revolution, How Cities Are Changing the World. These books valorize the city as an ideal with an optimism that has been critiqued by urban studies scholars such as Brendan Gleeson as boosterish. In his book, Ed Glazer promotes cities as mankind's best invention, while Leo Hollis seeks to develop a new argument of urbanism for our urban species, asserting that cities are good for us, and may be the best means to ensure our survival. Jeb Brugman argues for an urban advantage that serves as a public good, pointing out that the scale of the global city's mundane forces is so great that it has revolutionized Earth's ecology. In evoking urban complexity, these books imply that the self-organizing dynamics of the individual city can be exponentially scaled up to generate effects that would mitigate problems on a planetary level. But, as Brendan Gleeson notes, the genre's use of abstractions of urban complexity appears weak on epistemology. The arguments of the books reflect an amalgamation of city case studies and trends juxtaposed with theories of economic development, ecology, urbanism, and complexity science, of which Jane Jacobs' ideas form an anchoring influence. The authors reiterate existing arguments about the global city and the city as the seat of entrepreneurial and technological innovation. These books, as well as The Edifice of the Crystal, demonstrate how the trope of urban complexity, established through the ideas of Jane Jacobs and reframed by theoretical physicist Geoffrey West, have become the discursive basis of what architectural historian Antoine Picon terms as the social imagination of infrastructure, as shared by politicians and policymakers, architects and engineers around the world, who are invested in urban innovation, design, and management, as well as sustainable development. Ed Glaeser, Leo Hollis, and Jeff Brugman draw primarily upon the bottom-up urbanism that Jane Jacobs presents in The Death and Life of Great American Cities to discuss how vibrant community networks generate social capital and social cohesiveness that leads to more productive cities. In arguing for the advantages of compact urbanism and high urban density, the authors underscore the paradigm shift that Jacobs had brought to the problem of urban renewal in 20th century urban planning, whereby high urban density, defined as a high concentration of people within a given space engaged in a sufficiently diverse range of socio-economic interactions, becomes regarded as a positive feature. The authors identify urban density and proximity as key urban characteristics, along with economies of scale and the agglomerative dynamics of collaboration that extends within and across cities ranging from global cities such as New York to the entrepreneurial megacity slum Dharavi in Mumbai. Leo Hollis argues that large, dense cities are more creative, and its network of weak ties, diversity of parts, and the added competitiveness encourage innovation. In arguing that today's major global changes are rooted in more local material transformation, switching from building societies field by field and border to building societies and struggling to control them block by block, Brugman evokes Jacobs' ideas of how urban dynamics emerge between the smallest urban units from the ground up, instead of generated from the top down. Jacobs' notion of the city as analogous to a biological or ecological entity is evoked by the authors, especially Leo Hollis, who cites Jacobs as preferring the chaotic streetscape as the genome of the metropolis, by connecting scientist-mathematician Warren Weaver's notion of organized complexity to the case of the city. This idea is echoed in Glaeser's analogy that just as ant colonies do things that are far beyond the abilities of isolated insects, cities achieve much more than isolated humans, and in Brugman's explanation of how the city has been creating a quasi-ecological order parallel to the natural world. Jacobs is not the referential source of Glaeser's ant colony trope. She is not the first urban thinker to draw the analogy of the city to a living organism. Through her critique of density, Jacobs brought into urban planning and design perspectives from economics and sociology, which are disciplines of the social sciences that applied biological analogies, and later in the 20th century, complexity theory to the analysis of problems. Her identification of the city as a problem of organized complexity places her within a genealogy of the science of cities that sees cities as complex systems constitutive of systemic networks and physical flows. Leo Hollis explicitly establishes this connection in juxtaposing Jacobs' ideas on the complexity of the city with those of theoretical physicist Geoffrey West, who describes his research on cities as finding a way to scientifically confirm Jacobs' conjectures. While Jacobs used organized complexity as a heuristic to describe principles of how cities behave, West extends her analogy in registering socio-economic and physical interactions as material energy flows through enumerated data. In this quotation by Leo Hollis, Hollis describes the city as built on weak links. These links refer to human contact that act like electricity for the city. Here, social interaction is analogized and subsequently equated with the raw material of electrical energy, an energy that Hollis continues to describe as a strange power that feeds back into the fabric of the city itself, as Hollis introduces the research of Geoffrey West. West, a theoretical physicist, explains how cities organize and grow according to scaling laws similar to those of living organisms in his metabolic theory of cities. Utilizing network theory to analyze sets of statistical census data on aspects of the city such as the length of roads, electrical cables, as well as the wealth and wages of the city population, he explains how cities, in following patterns of sublinear scaling, require less energy and infrastructure per capita the bigger the city population size, like how larger-sized animals require less energy compared to their smaller counterparts due to greater biological metabolic efficiency. His theory corroborates with the author's arguments on the energy and infrastructural efficiency of dense cities and thus their sustainability. For West, physical infrastructure serves as the material networked medium, facilitating physical energy flows such as heat and light, as well as the energy of social metabolism, produced from interactive socio-economic networks that exchange information. Through West's analysis of data, the city's social and physical factors are made commensurable through calculable data units into energy flows. He also suggests that the city operates according to generic principles that, like biological organisms, transcend history, geography, and culture, and that it is possible to quantitatively predict the growth of cities, as he asserts that despite their amazing diversity and complexity across the globes, and despite localized urban planning, cities manifest a surprisingly coarse-grained simplicity, regularity, and predictability. West thus presents the city as a generic scalable figure, constitutive of systemic forms and logics replicable around the world. However, West's use of power law scaling has been criticized for not providing the strong predictions that he claims. Professor of Statistics Cosma Shalizi points out that West's scaling models of cities rests on an oddly monadic, interaction-free view of metropolitan areas, which reifies individual cities as separate from the larger regional economic networks they are embedded in. West himself notes that his claim of cities as approximately scaled versions of one another only pertains to the category of physical infrastructure, which is assumed to consist of self-similar units. West's analogy of the city as a biological organism also ends in comparing the growth patterns of the city with those of organisms and companies. Cities keep growing and persisting, unlike organisms and companies which eventually mature and die. This is reminiscent of Jane Jacobs's caveat that the problem of the biological organism is not the same as the problem of the city, but they are the same kind of problem. Given the epistemological limits to West's metabolic theory of the city, his ideas, along with Jane Jacobs's, are mobilized by the authors to present the city as a scalable infrastructural imaginary. In discussing the agglomerative interactions of the city, the authors imply that these nonlinear effects of socio-economic interactions scale up into agglomerative effects between cities that would create a positive aggregate planetary effect of creativity and innovation. For Glaser and Bruckmann, cities play crucial roles in the global knowledge economy. They argue that urban network efficiencies extend more globally through urban infrastructure, such as communications and information technologies and shipping networks, while Hollis describes the city as a superlinear site of information. This notion is materially manifested in The Crystal, Siemens's complex on urban complexity. As a showcase of technological solutions in urban research, its thematic emphasis on complexity reflects the social imagination of infrastructure projected by various stakeholders of global urban management, from politicians, policymakers to architects and engineers around the world, who are projected as producers and consumers of innovative infrastructure and infrastructure as innovation. Divided into various subzones showcasing different urban technological systems, such as transportation and security, the exhibits are designed to communicate to the layperson how to understand how all the different parts of the city can work together. Much as how Jane Jacobs had explained organized complexity as a sizable number of factors which are interrelated into an organic whole. However, the Crystal's synoptic presentation of urban systems and the technologies that increase energy efficiency and manage potential crisis runs counter to the microscopic or detailed view that Jacobs had offered of life on the street in The Death and Life of Great American Cities. For Jacobs, the life of cities was defined as the vibrant, spontaneous, physical, and also unarticulated social and economic interactions between different actors that emerged ground up in a particular space. In the case of global sustainable city discourse, life emerges from abstract forms of information exchange and the projection of scalar patterns to be calibrated and controlled.